Hello, in today's video we are talking about section 5.3, which is about SAS Triangle Congruence. Last time we talked about ASA Triangle Congruence. Today we're talking about SAS. So SAS Triangle Congruence. Okay, SAS, if you haven't guessed it yet, stands for side angle side. And what the theorem tells us is if we have two sides and an included angle, okay, so for instance, this side and this side with an included angle, if that is congruent to two sides and the included angle of another triangle, these two triangles are automatically congruent with each other. So side, angle, side. So let's look at example number 1 and see if we can use side, angle, side to decide if these two triangles are congruent. So our first side, we have this 19 centimeter, so that's a side. We have the angle 43 degrees, and we have the other side. So side, angle, side. In the other triangle, we also have a 19 centimeter side, a 20 centimeter side, but the degree or the angle in the middle is not the same. This angle was 43 degrees, this angle's 45. So this time our side, angle, side does not work because our angles are not congruent. So these triangles are not congruent. Example number 2. Again, we're trying to use side, angle, side to determine if these two triangles are congruent. So, side, angle, side. Want to see if it matches up in the other triangle. Side, angle, side. And they all have congruent measurements. So, yes, these two triangles are congruent. And our reasoning is the side, angle, side theorem. Now let's look at a proof. So first, we always need to look at our given. So we are given that BD is a perpendicular bisector of AC. Your given always goes in the top line. So BD is a perpendicular bisector of AC. That was given to us. Our job is to prove that triangle AB or triangle BDA is congruent to triangle BDC. That's what we're trying to prove. That always goes in the bottom of our proof. So we need to use this fact that BD is a perpendicular bisector to prove that the two triangles are congruent. So let's think about what the word perpendicular bisector means. A perpendicular bisector always makes a right angle, which we can see in the picture. And a perpendicular bisector always cuts a segment perfectly in half. So this bottom side of the triangle is being cut perfectly in half, which means this side must be congruent to this side. So just by applying the definition of perpendicular bisector, we can fill in some more information in our table. So first, right, we know that it makes a right angle. So angle BDA has to be congruent to angle BDC because they're both 90 degrees. And we know this because of the definition of perpendicular bisector. We also know that because it's cutting the bottom part of the triangle perfectly in half, that AD needs to be congruent to DC. And again, that's because of the definition of perpendicular bisector. But we need one more side to be able to use side, angle, side. Okay, right now we have a side and an angle. We need a third side. Well, just like in last class, right, BD is one line that is part of both triangles. So we can use the reflexive property to say that BD is congruent to itself. And now we have side, angle, side. Side, angle, side, congruent to a side, angle, side. So these two triangles must be congruent, and the reasoning is the SAS theorem.